Hello, good morning friends. Welcome to today's class. Let's start today's class with the thought, peace come from within, do not seek it outside. So today we will be discussing a topic from Mendelian genetics, the monohybrid and dihybrid cross. So we will be studying in detail. A brief of the lesson is here. So we will be studying the Mendelian genetics as Mendel conducted experiments on pea plant with the 7 contrasting traits of stem length, tall and dwarf, flower position, axile and terminal, flower color, colored versus white, pod shape, inflated versus constricted, pod color, green versus yellow, seed shape, round versus wrinkled, and seed color, yellow versus green. The different traits he experimented, and he made the monohybrid cross in which one set of contrasting trait is taken into consideration. The eventual steps for making the cross is described here. In step 1, you will be making a cross between a male plant and a female plant having the P1 phenotype in step 1, the tall and dwarf plants. In step 2, second line, you can write the P1 genotype, writing the alleles of the capital letters, capital T, that is homozygous nature for the tall plant and heterozygous nature, small t for the small plant. So in the third step, you will be explaining the gametes by encircling the letters or alleles in the respective rounds and making the probability of the F1 offsprings. You will be making the Punnett square and you will be writing the column in properly filled up form and writing on the side all the F1 offspring will be of the heterozygous tall. Then further proceeding to the second part, step 4, you have to write F1 into F1 gives F2, that is F1 on selfing will give F2. Again you will be explaining in step 5 the phenotype of the F1 individuals, tall versus tall, showing the F1 genotype in step number 6, that is capital D small t versus capital T small t. So when you will be making the gametes in the 7th step, you will be getting the next Punnett square of F2 individuals with 3 tall plants and 1 dwarf plant having the 3:1 ratio, that is the phenotypic ratio of monohybrid cross. Similarly, if you see the genotype, you will be seeing the capital T one time and the small t one time, in between the heterozygous capital T small t 2 times. So that is how you can represent the ratio as 1 capital T versus 2 capital T small t is to 1 small t, 1 is to 2 is to 1. This is the monohybrid cross. Okay. Then coming to the dihybrid cross, we will be considering any of the 2 sets of contrasting traits. Here we have considered pod color and flower color. So the dominant traits will be taken together, that is colored green versus white yellow. So here also you can see the same steps followed, like the same step P1 phenotype and P1 genotype, making the gametes by encircling the respective letters and making the cross for the F1 hybrid. Under step 4, you will be making the F1 versus F1 giving F2 generation on selfing. That is the phenotype, again you will be representing colored green with heterozygous nature, capital C small c versus capital G small g, and here also 2 of the same individuals of the F1 will be crossed. On crossing, you will be getting the different gametes and making the Punnett square to happen. You will be getting the ratio of 9 colored green is to 3 colored yellow is to 3 white green and 1 white yellow. Flower as the recessive trait. So 9 is to 3 is to 3 is to 1 ratio also is derived here. So by following the methods in a stepwise approach, you can make the ratios, both phenotypic and genotypic, in a simple way. Thank you for watching. Have a nice day.